And you should have gotten that f of negative 1 is equal to negative 1 squared. Yes? Yeah. What's negative 1 times negative 1? Positive 1. So your first point should have been negative 1 comma 1. We Gucci? Let's go. Then we did f of 0, which is 0 squared. What's 0 squared? 0. And 0 comma 0. Did we get that? That should have also been your vertex after you graph it. We on the same page? All right. And then the last one, f at 1. What'd you guys get?
1.
It was 1 squared, which is 1. So my point was 1 comma 1. Yes? All right. Those three, when we graph them, should have looked like this. Negative 1 comma 1, 0 comma 0, and 1 comma 1. Does your parabola look like mine for the first one?
Yes.
Let's go. Okay. The second one, the green one. Okay. The only difference here is what?
It's negative.
Brandon?
It's, there's plus 2.
There's a 2. Okay. We have to add 2. So when we plug in negative 1, check it out, guys. You're going to plug in f of negative 1 equals negative 1 squared plus 2. What do we do first? Square or add? Ronnie? Square. Why? PEMDAS, baby. Okay. Negative 1 squared is going to be 1. You add 2 to it. You get 3. So my point should have been negative 1 comma 3. Gucci? All right. F of 0 should have been 0 squared plus 2. That's 0 times 0, which is 0. Add 2 to 0. What do you get? 2. So 0 comma 2. We on the same page? All right. And my last one, f of 1 should have been 1 squared. You add 2 to that, you're going to get 1 plus 2, which is 3. So 1 comma 3. And once you graph them, this is where the beauty happens, people. Okay? Negative 1 comma 3 is all the way up here. 0 comma 2 and 1 comma 3. All right. These graphs are very similar, are they not? What's the only difference between them? Brandon?
The green one is up by 2.
The green one was moved up 2 units. This is a vertical shift up 2. Wow, my handwriting is very bad. Vertical shift up 2. No. Okay? All that the quiz will ask you is either graph this or tell me those 6 characteristics. Okay? Today we are looking at ax squared plus c. So yesterday, do you guys remember we just looked at ax squared? We're adding now the c term. What term are we still missing? Write that down, okay? We still have not introduced b. And b is going to have what next to it? It's the coefficient for x, okay? Remember, that term is going to be b times x. We are still not dealing with that term yet, okay? That will change some stuff when we look at it, all right? So all c is going to do is just like it did in our warm-up. It's not going to stretch. It's not going to shrink our graph. It's literally just going to shift it either up or down. It will not, I'll repeat this, it will not shift it horizontally at all. Got it? B will change what it does horizontally. C does not change it horizontally. Are we cool with that? Okay, so take a look at the first few examples, okay? If C is bigger than 0, that means C is positive, right? It's going to move our graph in what direction? Up. If C is smaller than 0, it's going to move our graph down. And if C is equal to 0, is it going to move our graph at all? No. Okay? So look at the 3 graphs. The green one is when C is shifted up. The blue one is when C is not shifted at all, which is 0. And the red one is when C is shifted down. Our graph is just shifted down. Any questions on those 3 examples? Okay, now look very closely. The only thing that's changing is your vertex, right? So when C is positive, right, the green one, you're shifting it up. Your new vertex is called 0, C. The y value of your vertex is the only thing that changes, and it becomes 0, C. Highlight that C in your vertex, okay? That is the only thing that's going to change with C. The examples we looked at yesterday, right? All of our vertexes were at 0, 0 when we had to graph it, right? Because it was just ax squared. Now, if your C is not 0, it's going to shift your graph either up or down. So that C value will carry over into the vertex, okay? Our axis of symmetry, though, will still always be at, please cross that out, the y equals 0, and change it to x equals 0. Okay? It's still going to be at x equals 0 because you're not shifting it horizontally at all, okay? It's still going to be down that line x equals 0. Isa, what's up?
So when the graph is like, when the C term is equal to 0,
Yeah.
your vertex is 0, like
0, comma?
C?
Yeah, but if C is 0, it would be 0, comma? 0.
Oh, so it's only 0, C when it's up and down.
Well, it's 0, comma C no matter what, when we're dealing with ax squared plus C, right?
Oh, no matter what.
But if C was 0, then it would still be 0, 0. Okay? Because yesterday, right, all those examples, C was 0, right? That's why our vertex was always at 0, comma 0. That's a good connection. All right, any other questions? Okay. Does changing C change the shape of your graph at all? No, and there's a note about it right here. The shape of your graph is not changing, okay? What value would change the shape of your graph? What value in here would change the shape of your graph? Brandon?
Yeah.
The x would not change the shape of your graph. Nope. The a term, okay? This will change the shape of your graph. Okay? But your C is just going to shift it up or down. Yep.
But isn't x what you stretch it out by?
So x, remember, we're never going to know x. We have to have x in there in order for it to be a quadratic. So x won't necessarily change our graph. It'll help us find points, right? But it won't shift our graph or stretch or shrink our graph. Okay? Alexandra?
So we would shape the shape of the graph.
The parabola, yep. So like if it's stretched, if it's skinnier, if it's shrunk so it's nice and wide.
So that's all on the A.
Correct. That's all what the A will tell us. All right, let's do some examples, okay? The first few are very easy, okay? The first one is g of x equals x squared minus 2. Go ahead and highlight that minus 2, guys. What do we think that minus 2 is going to do to our graph? Dougie, what do you think?
It's gonna go down to.
Yeah, very good. It's going to shift down 2 units. Is it going to be stretched or shrunk at all? No. Because what's my A value here? A equals 1. Yes? Do we see what I'm talking about? And if A is 1, we're not stretching or shrinking at all, okay? Is this parabola going to be upright or upside down? Upright. Why? It's not negative, okay? It's positive, all right? So the only transformation that's happening is that shift down 2 units, okay? Let's go ahead and plug it in and see what we get. So we're going to plug in g of negative 2. So we're going to plug in negative 2. We're going to get negative 2 squared minus 2. What do I do first? Square or subtract? Square. What's negative 2 squared? 4. You subtract 2 from it, you get? Dos. So my first point is que? Negative 2, comma 2. All right, you can walk me through the second one. Brandon, go for it.
It'll be g of negative 1 equals negative 1 squared minus 2. You square the negative 1 and you get positive 1. You subtract by 2 and you get negative 1.
Excellent. So my second point is what?
Negative 1 comma negative 1.
Negative 1, comma negative 1. All right, my third point. Cody B.
It would be g 0 equals 0 squared minus 2, and that would equal 2, negative 2.
Okay.
And then g of x would be negative 2.
Yep.
And then 0, negative 2.
0, comma negative 2. Bingo. Cody K. Do the fourth one.
So g parentheses 1
1 minus 2, yep, gives me negative 1. One comma negative 1, excellent. And my last one, Sophia.
It's gonna be D and then parentheses 2. It's gonna equal 2 in parentheses 2 minus 2.
Mm-hmm.
Which is gonna give you 4 minus 2 is equal to 2.
Good. So my last point is 2 comma 2. All right, guys, what I was super happy with is everyone squared before they subtracted, okay? We do that because PEMDAS tell us the order of operations. We have to deal with exponents before we can subtract. Cool beans? All right, we're going to remember PEMDAS on our quiz, correct? All right. So what do we do next? Isa? You graph it, okay? All right, we're going to plot negative 2 comma 2. That's up here. Negative 1, negative 1. 0, negative 2, 1, negative 1, and 2, comma 2. And you're going to get a parabola. How pretty. All right, somebody tell me what is the only thing that changed from our parent parabola?
Everything went down by 2.
It just went down 2 units, okay? We shifted it down 2 units. What is my new vertex here? Brandon? 0, comma, negative 2. And we knew that from the start, right? Because what was our C value? Negative 2, right? And our vertex is just 0, comma, C. Do you guys agree? So in this case, it was 0, comma, negative 2. Yes?
So C is always going to be the y value?
C will always be the y value of your vertex, okay? All right, now, where's my axis of symmetry? Shayla? X equals 0. Very good, okay? Does that change with my C value? No, okay? My axis of symmetry is going to stay the same. What's the domain here? Isa?
Wait, I have a question. All real numbers, but I have wait, is it
It is all real numbers, yes. What's your question?
I don't get like okay, so if on the quiz you have to write the vertex, like you have to find the
No. Only if it asks you to find the vertex.
I know, but like let's say you have to and
Yeah.
then you graph like that with like the C term. Do you put 0, comma C?
Yes.
0,
No,
and then
0, comma, and then the number. If it asks you for the vertex, it wants the specific coordinates.
So you don't put C.
You don't have to put C. No. Okay? All right. So what's the range? Cody?
Y greater than or equal to negative 2.
Excellent. Where's my function? This is the hard one. Increasing. Brandon?
When x is greater than 0.
Good. When x is bigger than 0. Do you see how my graph is going up over here to the right of 0? When is my function decreasing? Someone new. Adam.
X is less than 0.
Very good. X is less than 0. Okay? If you can figure out one of them, you can figure out the other one just by flipping the inequality. Okay? Kevin, what's up? No. Let's take care of business. First off, what do we think is going to happen here? Brandon?
Shift down by 5.
Shift down by 5. Why do we think it's a shift down by 5? Isa? It's the C term, and it's a negative. Very good. Okay, so we're shifting it down by 5 units. Let's go ahead and take care of business. What would happen when I plug in negative 2? Zach, walk me through it.
G and parentheses negative 5 equals negative 5 squared minus 5.
Okay. Yep.
That would be negative 25 minus 5. No, positive.
Positive 25? Yep.
That would be 30.
Okay. Wait.
Wait, that's wrong.
It'd be 20, okay? Now, you plugged in negative 5, right? But what x value should I be plugging in?
Oh,
Negative 2, okay? So switch those 5s to 2s. Oops. Switch those 5s to 2s. Why isn't it erasing? There we go. And instead, when we square negative 2, we should get 4, right? And 4 minus 5 is going to give me negative 1, right? So my first point is negative 2 comma negative 1. What's my next point going to be? G of negative 1. Veronica. Mm-hmm. Mm-hmm. Good. Good. Gabby George, next one. Good. Zero, negative 5. Ronnie, can you do the next one for me?
G of 1 equals 1 to the second power.
Mm-hmm.
And then you do 1 minus 5. And you get negative 4. And you get 1, negative.
Perfect. Arian, can you do the last one, please?
So, if you plug in the x into x, or the 2 into x,
Mm-hmm.
you get 4, and 4 minus 5 is negative 1.
Yep. So what's my point?
It is 2 negative 5.
Beautiful. All right, so once I plot all of these, I'm going to see that the only shift I'm going to do is moving it down by 5. It should still be right side up, like a regular U-shaped parabola, because my A value is not negative, okay? My A value is 1. So negative 2, negative 1, negative 1, negative 4, 0, negative 5, 1, negative 4, and 2, negative 1. Wow, that was one of my worst ones. That's better. Ronnie, what's up?
You have to put the arrows, right?
Yes, you have to put the arrows, okay? Because this graph is going on forever. You can plug in whatever x value that you want, okay? Yeah.
You know, if you like do the curve and hold it down for a while.
Okay, so are we good on those first two examples? All right. We're not going to do... Oh my goodness. All of the third one, okay? We're just going to talk about it. What would a plus 3 do, peeps? Brandon? It would shift it up by 3. Are we cool with that C term being not 0? Yes? All right, let's do a few examples where we have an A term and a C term, and then we'll call it a day, okay? All right, check out the first one. We've got 4x plus 1. A is equal to 4. C is equal to 1. A equals 4 means what's happening to our graph, guys? It's a vertical stretch by what? Good. Why is it a stretch and not a shrink? 4 is bigger than 1. Okay, so we're stretching it out by 4. What is the 1 doing from the C term?
Vertical shift up 1.
Good. It's a vertical shift. Shift up 1. And will vertically stretching my graph make it skinnier or more bowl-shaped? Skinnier, okay? So, do you have to know this for the quiz? No. But it is helpful so that when you finish your graph, you can be like, oh, that looks like what I was anticipating to get, right? So you know what the transformations are going to look like, okay? All right, so let's take care of business. Let's do the first one, g of negative 2, okay? G of negative 2 is going to be 4 times negative 2 squared plus 1. All right, now we've got some stuff going on. What do I take care of first, Cody?
You take care of the parentheses, so you square 2, this will be 4, and then you multiply 4 by 4, which is 16, and add 1.
I'm so glad you said that. You are actually 100% right, but let me correct how you said it, okay? When we're talking about PEMDAS, right? P stands for parentheses, agreed? You're only looking at the inside of your parentheses. Is there anything to simplify inside the parentheses? No. Negative 2, can it be simplified at all? No, there's no operations in there. What comes next after P? Exponents. So that's why we square first. But Cody, you're absolutely right, okay? You went in the right order and everything, okay? But we are using exponents, not parentheses, okay? So negative 2 squared will give me positive 4, so it's going to be 4 times 4, and then add 1. Do not add 1 yet, because what operation is still there? Multiplication. Multiply first. What's 4 times 4, peeps? 16. What happens when you add 16 and 1 together? 17. So our first point is the whole point. Negative 2 comma 17. Who wants to take over and do negative 1? Gabby, go for it.
So you replace x with -1, and it would be -4 in parentheses -1 to the second power plus 1.
Mm-hmm.
And -1 to the second power is +1, so it would be -4 times 1 plus 1. And -4 times 1 is still -4.
Wait, why'd you get negative 4?
If you square it, it's going to be 20.
I think it should be a positive. You didn't write negative 4? Oh, okay. Be careful with that, okay? Because all of your points would then be the wrong sign, okay? So it should be positive 4 times positive 1, which is 4 plus 1. You should have gotten 5, right? Okay. So the next point is negative 1 comma 5. All right, Issa, do the third one.
Okay, so you do g and then g of 0. So then that would be equal and then 4 parentheses 0 squared.
Yep.
And 0 squared, plus 1. And 0 squared is just 0. So then 0 times 4 is 0. And then 0 plus 1 is 1. So the point would be 0, comma 1.
Good. 0 comma 1. Is this my vertex?
Yeah.
How do I know?
Because
The C term. Do you guys see that? When that C term becomes your Y value, you know that point is your vertex. Cool beans? All right. So we do 1. We're going to get G of 1 equals 4 times 1 squared plus 1. 1 squared is 1. 4 times 1 is 4. 4 plus 1 is 5. So the next point is 1 comma 5. And the last one, G of 2. We're going to get 4 times 2 squared plus 1 is going to be 16 plus 1, which gives me 17. And that last point is 2 comma 17. All right, the first and the last points are not going to fit on my graph, so I'm just going to do the middle 3. Negative 1 comma positive 5, all the way up here. 0 comma 1, and 1 comma 5. What do you notice about this graph? It's shifted up by 1. What else, Ronnie?
It's closer together.
It's very skinny. Yeah, very good. It got skinnier because of the vertical stretch by 4, and it shifted up 1 because of the plus 1. Cool beans? Any questions on this one? All right. Your challenge is example C. As a group, work on it. The first group done, you only get 1 chance to check it, gets candy. Go. Peeps, you should have gotten h of 0 equals negative 1/4 times 0 squared plus 4. Yes? You're going to get 0 for that left side, or the left term, and you're just going to have 0 plus 4, which is 4. So your first point should have been 0 comma? Did we all get that? Yeah. Any questions on that one? Okay? So you should have had a vertex at 0 comma 4, which I saw a lot of. Okay? Your next point, okay, that I'm going to go over will be negative 4. So h at negative 4 is going to be negative 1/4 times negative 4 squared plus 4. You guys, negative 4 squared is negative 4 times negative 4, which will give you a positive 16. Not a negative 8 and not a positive 8, a positive 16, okay? So that's negative 1/4 times positive 16 plus 4. Multiply before you add, and you should get that this is going to be negative 4 plus 4, which will give you 0. Your second point should have been negative 4 comma 0, and you should have gotten the same thing down here, 4 comma 0. So your next 2 points should have been negative 4 0 and 4 0. Yes? Okay. Let's do negative 8. h of a negative 8 equals negative 1/4 times negative 8 squared plus 4. Yes? What is negative 8 squared?
64.
Positive 64. Negative 1/4 times 64 plus 4. Negative 1/4 times 64 gives you negative 16 plus 4 gives you negative 12.
Oh.
This point is negative 8 comma negative 12. Do we see it now? And you should have gotten 8 comma negative 12 as your last point. So then these two are at the very edge of your graph, right down here and right down here. So you needed to connect all of these to have a nice fat parabola that looks like this. Do we see it? Expect fractions on your quizzo, okay? All right. Question, why is my graph facing down? Brandon? It was negative, okay? Why is my graph wider than before? Ronnie? It shrunk by how much? 1/4. And why is it shifted up 4 units? Dougie?
Because there's a plus 4 at the end.
There's a plus 4, baby. Okay? Are we Gucci? Any questions? Turn these in.